Hey everyone, Linus here. Today we're diving into the world of virtual circuits, a reliable way to transfer data across networks. Think of sending a letter versus shouting in a crowded room. Sending a letter is like using a virtual circuit. It's a direct, dedicated connection between you and the recipient. Datagram networks, on the other hand, are like shouting in that crowded room. You just send your data packets out and hope they reach their destination. There's no guaranteed path or order of arrival. Virtual circuits are connection-oriented, meaning a dedicated path is established before any data is sent. It's like having a private phone call, ensuring your data packets arrive in the correct order and without interference. Datagram networks, however, are connectionless. They're more like sending postcards. You send them out and hope for the best. They're efficient for broadcasting information, but lack the reliability and order of virtual circuits. So how do virtual circuits guarantee this reliability? It all starts with setting up the connection. Before any data is transmitted, a virtual circuit establishes a dedicated path through the network, reserving resources along the way. Think of it like booking a flight. You're reserving a seat on a specific plane, ensuring you have a spot. In a virtual circuit, resources like buffers, temporary data storage, CPU power and bandwidth, data transfer capacity, are reserved. This guarantees that your data has the resources it needs to travel smoothly and efficiently to its destination. This reservation process ensures that once the connection is established, your data has a clear and dedicated path to follow, minimizing delays and ensuring reliable delivery. Now, let's talk about how data actually travels through a virtual circuit. Data is divided into packets, kind of like putting your belongings into suitcases before a trip. Each packet travels through the network, following the pre-established path. The first packet is special. It carries a global header containing all the necessary information about the virtual circuit. This header is like the address label on your suitcase, telling the network where the packet needs to go. As the packets travel through the network, each router, a device that directs network traffic, uses the information in the header to forward them along the correct path. Section 4. Reliability is key. Order and assurance in virtual circuits. The real magic of virtual circuits lies in their reliability. Since all packets follow the same predefined path, they arrive at their destination in the correct order, just like your suitcases arriving at the baggage claim in sequence. This ordered delivery is crucial for applications that require data integrity. Imagine streaming a video. You need the video frames to arrive in order for it to play correctly. Moreover, virtual circuits offer error control mechanisms. If a packet gets lost or corrupted along the way, the virtual circuit can detect the error and request a retransmission. This ensures that all data arrives at its destination intact and in the correct sequence. Section 5. Virtual circuits in action, ATM networks and beyond. So where are virtual circuits used in the real world? One prominent example is asynchronous transfer mode, ATM, networks, a technology used for high-speed data transmission. ATM networks utilize virtual circuits to transmit various types of data, including voice, video and data, all over a single network. Think of it like a superhighway for data, with dedicated lanes for different types of traffic. Virtual circuits are particularly well suited for applications that require real-time communication and guaranteed quality of service, like video conferencing or online gaming. Section 6. PVCs and SVCs, permanent versus on-demand connections. Now, within virtual circuits, we have two main types: permanent virtual circuits, PVCs, and switched virtual circuits, SVCs. PVCs are like dedicated phone lines. They're always connected and ready to go. They're great for applications requiring a constant connection, like connecting two office branches. SVCs, on the other hand, are more like dialing a phone number. The connection is established only when needed and disconnected afterward. They're more flexible and cost-effective for applications with sporadic data transfer needs. Both PVCs and SVCs have their pros and cons, and the choice depends on the specific application's requirements.